one is going to be over the Chapter 5 review. So your Chapter 5 review and test will be due this Sunday. Okay, so going into Chapter 5 review, the first question is on just how to write an expression with its exponent, how it will be written in an exponential form. So you've got a problem, it looks like this, 7 times 7. Like this. Okay, so the first thing you're going to do is to ask yourself, how many times is that 7 being multiplied together? So the base is going to be the number that is multiplied over and over, which is the 7. The exponent is going to be however many times you're multiplying that 7 together. So you just count 1, 2, 3, 4, 5, 6. So that would be like saying 7 to the 6th power. Okay, and it wants you to leave it just like that. It's actually multiple choice. So you would know that you didn't need to actually type that in your calculator to figure out what 7 to the 6th is. It just wants you to rewrite it as an exponent. Right, number 2. Says to use the product rule. Now remember, when you're taking this test, I would have my exponent rules that I've written down handy. Okay, so when it says use the product rule, you can look that up actually. You have y to the 4th times y to the 9th times y to the 8th. So what does the product rule say? It says when you are multiplying the same bases together, you are going to add their exponents. So I'm multiplying all these y's together, which means I am just going to add all 3 of those exponents together, which will give me y to the 4 plus 9 plus 8. And then add that together. 4 plus 9 gives me 13. 13 plus 8 gives me 21. So y to the 21st power. So again, multiplying the same bases, you're just going to add those exponents together. Right, number 3. All right, I've got negative 7x to the 8th times 3x to the 4th. Now remember that the exponent rules just apply to exponents. You're still multiplying, so I'm still multiplying negative 7 times positive 3 here. So when I multiply, just like always, negative 7 times positive 3 gives me negative 21. So since I'm multiplying these x's together, that just means I'll add those exponents, which gives me x to the 12th. Right, number 4. So it says to simplify this expression. So the only thing that can happen here, since these aren't the same bases, I can't add their exponents. It just doesn't like this negative exponent, right? You can't leave an answer with a negative exponent, which means rewrite this and put the Q, since it's the one with the negative exponent, in the bottom of the fraction bar. So think of your fraction bar as being below it since you don't see it. So p to the 6 is good where it is. The q needs, moving it to the bottom of the fraction bar makes it positive 9. So you just have to write it with a positive exponent. Let me check that email real quick and make sure that's not. So Michelle is trying to join and she can't for some reason. For some reason it's saying she's trying to join the college algebra Zoom link. I wonder how she even got that. Hang on, let me see. She's trying to get in. Oh, shoot. Oh, there you are, Michelle. Okay, so we have done 1, 2, 3, and 4. This is number 4 that we just did. And it goes over, this q needed to go to the bottom of the fraction bar since its exponent was negative. And so you had to fix it by putting it in the bottom of the fraction bar. Okay, let's look at number 5. Okay, so it's a division problem. That's what that fraction bar says. So if we are dividing the same bases, I'm going to subtract the top exponent minus the bottom exponent and see where that gets me. So on my 6's, if I subtract my top exponent minus my bottom exponent, I'll have 5 minus 7, which gives me negative 2. So we're going to have to fix that in a minute. X to the 8th over x squared, if I subtract their exponents, 8 minus 2 gives me 6. So when I see that written out, I see the 6 needs to be fixed because it has a negative exponent, which means I need to think of my fraction bar as right there, and then fix the 6. So let's see, the x to the 6 is fine where it is. It's the 6 that needs to come to the bottom. When I put it in the bottom, it makes the exponent be positive 2. And then it wants me to take that one step further, right? Because in the denominator, what is 6 squared? What does that mean to do? 6 squared means to multiply 6 times itself. So I'm ended up with x to the 6th in the top, 6 squared in the bottom, which gives me 36. All right, number 6. Okay, so this one says to combine like terms if possible. So if I'm looking at these two terms, if they're like, what are they going to have? They're going to have the same letter, and that letter will have the same exponent. So when I'm looking at these, they both are n squareds, which means we can put them all in the same basket, right? Now, I'm not multiplying. That's when you add your exponents. If you are just putting same terms together in the same basket, the exponent stays the same. Okay, so if you've got negative 8 n squareds and you put that together with positive 3 n squareds, negative 8 plus 3, you're just going to be left with negative 5 of the n squareds. Okay, again, you only add exponents when you are working a multiplication problem, not when you are just combining like terms together. Right, number 7. Says evaluate the polynomial for x equals 1. So x equals 1, and here's the polynomial. And polynomial is just a fancy way to say the group of terms. So you've got 3x squared minus 4x plus 8. So I'm going to evaluate this for x equals 1. What that means to do is you go to this group of terms here, and everywhere you see an x, you're going to replace it with a 1. So let's do that. I have 3 times 1 squared minus 4. Replace that x with a 1 plus 8. So let's see what we got. Take care of your exponent first. You can't do 3 times 1 here, because in your order of operations, your exponent has to be taken care of before you can do any multiplying. So I need to turn, what is 1 squared? Well, 1 squared means to multiply just 1 times 1. So it's really just 1. So just 3 times 1. I'm just going to bring the rest of this down. So now you do your multiplying. So 3 times 1 gives me 3. Minus 4 times 1 gives me 4. Bring down my plus 8. And the last step is to just do your adding and subtracting from the left side to the right side. So 3 minus 4 gives me, I'm just doing this part right here, so that's negative 1. Bringing down that plus 8. So negative 1 plus 8 gives me 7. Right, number 8. Subtract 14x to the 6th minus x to the 4th. Then subtract that from, or subtract this from here. So 9x to the 6th plus 3x to the 4th. So when you're subtracting, remember this minus goes to everything that you're subtracting here. So let's see, that makes this 4, and these are like terms, right? They're both x to the 6's, which means I can subtract those. So I've got 14x to the 6's minus 9x to the 6's, which leaves you with 5x to the 6's. It also turns this into a minus, right? It changes this sign. So I've really got here, up here, I've got negative 1 minus 3. So make sure that you know that this minus also comes here and changes this sign to a minus. So you've got negative 1 minus 3, which gives me negative 4. And what do you have negative 4 of? X to the 4th. Right? Number 9 is also another subtraction problem. Instead of putting one on top of the other, it's going to write them next to each other, which I actually like better. So I've got 6x to the 4th plus 6x to the 3rd minus 9. Close that parenthesis and then subtract, open parentheses, 3x squared minus 6x plus 1. So the very first thing I do when I see a minus in front of a parenthesis, that's telling me I need to distribute that and go in there and change all those signs. That takes care of the subtraction part of the problem. So I'm just going to rewrite this whole problem, but I'm going to distribute that negative to change those signs. So all this stays the same. So I've got 6x to the 4th plus 6x to the 3rd minus 9. That turns this to minus 3x squared. It actually turns this, since it is minus, it turns it into plus 6x. Since that's a plus, it turns it to minus 1. That takes care of the word subtraction. Now you are just combining like terms, and when you do that, you always start with the highest exponent and then go down from there. So looking for the term with the highest exponent, which is that front term, are there any other x to the 4th to put with this one? So when I'm looking at all these terms, I don't see any other x to the 4th. So it's just by itself. Once I do that, I'm going to go ahead and say, okay, I've taken care of that term. I don't even need to look at it anymore. Now, after x to the 4th or x to the 3rd, here's an x to the 3rd. When I'm looking for other x to the 3rds, I don't see any, so it's by itself. And then I'm done with my x to the 3rds. So now I'm looking for x to the 2nds. When I'm looking for x to the 2nds, here's the only one I see. There's no other x squareds to put it with, so I'll just bring it down. Minus 3x squared, which means now I'm done with my x squareds. After x squareds come x's. This is my only x. So I'm just bringing down my plus 6x, and I'm done with my x's. So really the only terms that would go together are those plain number terms that don't have any x's on them. But they are like terms. So I can put the negative 9 minus 1, which would give me negative 10. So that's the only two terms that I could actually combine. All right, number 10. m squared plus 5m minus 8. Close that parentheses, then minus, open another one, 5m cubed minus 4m plus 9. Close that parenthesis, close that bracket, minus, oh shoot, I'm running out of room. So here's what the problem looks like. The very first thing I'm going to do, again, just like the last one, I'm going to rewrite the whole thing, and any parenthesis that has a minus in front of it, I'm going to distribute it to change the signs inside that parenthesis. And then I'm just going to combine like terms. So in other words, I'm going to distribute this negative to all those. And then I'm going to distribute this negative to those terms. So that's going to remove all the brackets, all the parentheses. I'm going to have a whole bunch of terms, And then I'm going to combine my like terms, starting with the highest exponent again, just like the last one. So let's see. This one I'm just going to bring down, right? There's no negative in front of it. So I can just bring down the 9m squared plus 5m minus 8. Here I'm going to distribute this negative, which is going to change all those signs. So negative 5m to the third plus 4m minus 9. So again, just change all three of those signs. And I'm also going to distribute the negative to these, which makes that a minus m squared and this a minus m. So once I have done that, now I'm going to combine like terms. And remember, always starting with the highest exponent. So when I'm going through and I'm looking for the highest exponent, it's this term, right? That's my highest exponent. Are there any other m to the thirds? When I'm looking at all these, I don't see any other m to the third. So it's just going to be all by itself with its sign. So that's negative 5m to the third. And again, once I bring it down, I'm going to cross it out so I don't have to worry about it anymore. After m to the thirds come m squared. So let's see, I've got an m squared here and an m squared here. So I'm going to put those together. So I've got 9 here minus 1 there. So 9 minus 1 gives me positive 8 m squared. And once again, when I'm done with them, so I'm not confusing myself, I'm just going to mark them out. Done with the m squareds. After m squareds come m's. So let's see, here's an m, here's an m, and here's an m. So let's put all those together. So I've got 5 plus 4. So there's 9. 9 minus 1. So I also have positive 8 m's. So again, 5 here, 4 here. That's what gave me 9. But then I had to subtract 1 for this one. So that's what left me up with the 8. So I'm done with the m's. So done with that, and done with that. So after m's comes your constants, your plain numbers. So let's see, I've got a plain number left here and a plain number left here. Those are all that's left. So I've got negative 8 minus 9. Again, if you want to punch that in your calculator, you go right ahead. Type in negative 8 minus 9, which would actually give you negative 17. There is no shame in using a calculator to do stuff like that. All right, getting to number 11. This is when we're getting into the multiplying section. In the multiplying section, that's when we are going to be multiplying x's together, which means we will use that exponent rule. When you multiply x's together, you're going to add their exponents. So let's look at number 11. So I'm going to be distributing, multiplying. This term is going to multiply times all those terms. So let's see what I got. The first thing I have that I'm multiplying is negative 5x squared times negative 7x squared. So just like always, negative 5 times negative 7, a negative times a negative gives me positive 35. When you multiply these x's together, you're going to add those exponents. So x squared gives me x to the 4th. Now, when I'm looking at this x, remember, that's like a 1x to the 1st power. So I'm multiplying negative 5 times positive 1, which gives me negative 5. This is why I wrote this 1 right here, because I have x squared times x to the 1st power, and the rule tells me I'm supposed to add their exponents, so that's going to give me x to the 3rd. And then the last one, negative 5 times negative 2 gives me positive 10. Now you've got x squared. There's just no more x's to add any more exponent to that. So it's just going to stay x squared, right? This one doesn't have any x's to change, to add to that x squared. So it just stays x squared right there. All right, number 12 is another multiplying, and remember the FOIL acronym that we learned. When you have two parentheses, and each of those parentheses have two terms in them, you can use that FOIL acronym, which stands for first, outer, inner, and last. And essentially all you're doing is distributing, just like you did on the last problem. This just gives you the order. When I say first, I'm talking the first thing you're going to do is multiply the first term in this parenthesis times the first term in the other parenthesis. That's what first means. So x times x, right? They both have a 1 exponent. So when you multiply them together, you're going to get x to the 2nd. So I've done my first. Now I'm going to move to my outer, which means the very outside two terms from each other. So this one times the outside of the other one. When you multiply a letter times a number, it just hooks them together. So I've got x times positive 8, which is just positive 8x. So I'm done with my outer, moving to my inner. The inner means the two very inside-most terms. Again, multiplying a number times a letter just hooks them together, so plus 5x. And then last means the last term of this parentheses times the last term of the other parentheses. So I've got positive 5 times positive 8, which is positive 40. Now, remember, almost always when you FOIL, you're going to end up with those two middle terms being like terms, which means they need to be in the same basket, right? Now, here's the tricky part. I'm putting them in the same basket, which means not changing their exponent, right? I'm just putting them in together to be just one term instead of two. If you're like terms, there's no reason to write you separately. So I have x squared, putting my x's together, I really have 13x, bring down my plus 40. All right, number 13. All right, I left FOIL here, even though it doesn't look like a FOIL problem right now, it's actually going to be one, right? FOIL problems are for 2 parentheses, and each parenthesis has 2 terms in it. But what does 8x minus 7 squared actually mean? It means 8x minus 7 times itself. 8x minus 7. So when I FOIL this, my first 8x times 8x. 8 times 8 gives me 64. Multiplying the x's, so that gives me x squared. Outer. I've got positive 8x times negative 7. So positive 8 times negative 7 gives me negative 56x, right? This one has an x, so it's got to keep an x. 8x times 7 gives me 56x with the negative. That's my outer. Now to my inner. Negative 7 times positive 8 again, so that's going to give me another negative 56x. And my last, negative 7 times negative 7. So since negative times a negative, it's going to give me positive 49. And again, remember, when you FOIL, there's a good chance of those being like terms. So be careful here. Those do not cancel each other out. They have the same sign. So that's actually, what do I need to know? I need to know if I'm putting these in the same basket, since they're both x's, I need to know what's negative 56 minus 56. So I would definitely type that in my calculator. So just, again, negative 56, then minus 56. So altogether, that's how many x's I really have. Negative 112. So I'm putting these all together. So I've got 64 x squared. And then like my calculator says, I have negative 112 x's. Bring down your plus 49. Right, number 14. Okay, so remember this right here. They were both had the same signs, which means it doesn't cancel each other out. I just need to punch that in my calculator to see what negative 56 minus 56 was. On this one, let's see what happens. I've got 5v plus 4t. Times 5v minus 4t. FOIL again. Your first 5v times another 5b. So 5 times 5 gives me 25 bv, which is b squared. Your outer, which will be positive 5b times negative 4t. So let's see, I've got a positive 5 times a negative 4, which gives me a negative 20. And I've got v times t. Okay? When you're multiplying 2 different letters together, it just hooks them together. Okay? But, let me check something. When I do that, when I'm multiplying 2 things together and it has 2 different letters and it hooks them together, you can hook them together any way you want. It could be VT or TV. It can be either way. but I always like to write them in alphabetical order when I hook them together, so that later on, if I'm looking for like terms, it's going to be clear that those are going to be like terms with each other. So when I hook the V and T together, I'm actually going to write it as TV just to put them in the alphabetical order. You can write that as VT if you want. My inner, I have a positive 4T times a positive 5V. So it's going to give me positive 20. Again, hook your letters together in alphabetical order. So it's going to be TV. And my last, I have a positive 4T times a negative 4T. Positive 4 times negative 4 gives me negative 16. And what do you get when you multiply T times T? Since they're the same letter, you're going to add their exponents. Now, here's why I said I like to write the letters in alphabetical order, is because now look at the middle two terms. They're both TVs, which means they are the same kind of term, which means I do want to put them together. Now, here I've got negative 20 of them, and here I have positive 20 of them. And even if you weren't sure and you type that in your calculator, negative 20 plus 20, look what it gives you. Nothing. You don't have any TVs anymore. They canceled each other out because you have a negative and positive of the same number. So they just completely canceled each other out. So all you're left with is the 25V squared and the minus 16T squared. All right, number 15. This one's a little bit different, and actually we haven't seen this all the way yet. So here's something new that we actually haven't seen, but it's not that big of a deal. The only thing that's different from this just being a straight FOIL problem is this P. So we're multiplying. You can multiply numbers in any order that you want. So I don't have to do anything. There's no order that I have to do this. So I'm actually just going to hold off on this P. I'm going to FOIL these two parentheses together. And then I'll bring down the P and put it in front of that, and you'll see what happens with it. So again, I'm just going to worry about this P later. I'm going to FOIL here. 3P times 3P gives me 9P squared. My outer, 3P times negative 1. So when you multiply something times negative 1, it just changes the sign, right? So 3P times negative 1 just makes it negative 3P. My inner, positive 1 times 3P is just positive 3P. And my last, positive 1 times negative 1 is negative 1. Now, there's my like terms, and again, they're positive and negative of the same number. So they just cancel each other out. So I just have 9P squared minus 1. Now, here's where I'm going to bring down the P. The P is still times that. So when I bring down this P right here, it's still going to be times whatever I got after I FOILed, which means I'm just going to distribute it there. So I have P times 9P squared. So again, I'm going to add the exponents on the P's. So that's just going to give me 9P to the third. So now I have P times negative 1. So when you multiply the P times negative 1, when you multiply anything times negative 1, it just changes the sign of what you're multiplying. So let's see, a positive p times negative 1 just changes it into a negative p. And that's it on that one. Now, getting into number 16 is what we covered today in 5.7, the division. So this is the 5.7 stuff that we just covered. So again, if you've got a fraction bar and you've got this one denominator, it's actually the denominator of all those terms up there. So this is when we like to write them separately so you can see everybody as their own separate fraction. So I've got 6x to the 4th over 2x minus 4x to the 3rd over 2x. So we're going to be dividing here, which means I'm going to be subtracting exponents. So I need to remember those x's have one exponents. So I've got 6 divided by 2, which gives me 3. X to the 4th over x to the 1st gives me x to the 3rd because I subtract those exponents. Minus 4 divided by 2 gives me 2. Subtract my exponents again to get x squared. All right, number 17, same kind of problem. Right, 18x to the 5th minus 6x to the 4th plus 10x squared over negative 2x squared. So again, like I said, even though it takes a little more work on the front end, I like to see everybody separately, which means I have 18x to the 5th over its own negative 2x squared, then the minus 6x to the 4th over negative 2x squared and positive 10x squared over negative 2x squared. So let's do this division. 18 divided by negative 2 gives me negative 9. Subtract these exponents. That gives me x to the 3rd. This one, I've got negative divided by a negative, which actually turns me into a positive. 6 over 2 is 3. Subtract these exponents, which gives me x squared. And the last one, a positive 10 divided by negative 2 gives me negative 5. And when you subtract those exponents, you don't have any x's left. So it's just minus 5 there at the end. Excuse me. All right, number 18. Excuse me, I can't ever see. Negative 7r to the fourth plus r to the third minus 2r squared over negative r to the third. So I'm going to write them all separately. Negative 7r to the fourth over negative r to the third plus r to the third over negative r to the third minus 2r squared over its own negative r to the third. So remember, all these r's are negative ones. So negative divided by negative. Negative 7 divided by negative 1 actually gives me positive 7. Subtract your exponents. So you've got r to the fourth and r to the third. So when I subtract those exponents, I'm just going to be left with r to the first, which is just r. My second fraction, I've got a positive 1 divided by a negative 1. Well, positive 1 divided by negative 1 is negative 1. And those r's cancel. And the last one, negative 2 divided by negative 1. So negative divided by negative gives me positive 2. When I subtract these exponents, I have 2 minus 3, which gives me r to the negative 1 there. You can't leave your answer with that negative exponent, so the r needs to go to the bottom of the fraction bar to fix that negative exponent. So I'm just going to rewrite the rest, 7r minus 1. The 2 is fine where it is. It's the r that needed to go into the bottom to fix its negative exponent. Two more. Number 19 is another multiply. Five x times 2x plus 7 So I'm going to distribute this 5x to both of those. So I've got 5x times 2x. So that's going to give me positive 10. So I have x. So if I add those exponents, I actually have x squared. And then I multiply the positive 5x times positive 7. So 5x times 7 gives me positive 35x. And the last one, which has actually got 4 problems. So this last one actually has 4 in it, it looks like. All right, the first two are going to be multiplying, so we're going to add those exponents. So I've got positive 5, x to the third, times positive 7, x to the 6. So let's see, positive 5 times positive 7 gives me 35, x to the third times x to the 6. So I'm multiplying, so I'm going to add those exponents to get x to the 9th. Next one. Negative 5 times positive 7. So now it gives me negative 35. And when you add, so I'm multiplying still, so I'm adding the exponents over the x's. So x to the 6, x to the third gives me x to the 9th. Now, that we haven't had this yet, I'll just review. This is the other exponent rule that we talked about in this chapter, is when you are raising an exponent or an x to more than one exponent, you're going to multiply those exponents together. Now, that doesn't have anything to do with what's going on here. Everything in this parenthesis is being raised to the third power. So 5 to the third. 5 is not an exponent. It doesn't follow any kind of exponent rules. 5 to the third power means 5 times 5 times 5. Right? If you're raising something to the third power, that means to multiply it times itself 3 times. So when you multiply 5 times 5 times 5, you get 125. Now is when I use the exponent rule, right? I've got an x that has 2 exponents. That's when I'm going to multiply the exponents together. So I've got x to the 6th and 3rd, which means this is what I multiply right there, which gives me x to the 18th. And the last one. So here's what I'm going to multiply. But negative 7 is also to the third power. If you wanted to type that in your calculator, you would type it in as, if you're doing a negative in parentheses, it needs to be in parentheses here also. So open parentheses, negative 7, close parentheses. So what power am I raising that to? To the third power. Negative 7 to the third power. Now remember how you get up in your exponent, this little up arrow right here? Watch my cursor when I push the up arrow. It moves it up into the exponent. And that's when I'll put in the third power. So negative 7 to the third power gives me negative 343. Because negative 7 to the third power means negative 7 times negative 7 times negative 7. So that's why it got so big. Negative 343. Here's my exponent rule. The x is being raised to 2 exponents, so I'm going to multiply them together to get x to the 9th. Okay, so I got y'all all here. Michelle, Carrie, Brittany, Lauren, and Kayla are all counted as present. So again, I'm going to stop the meeting. No, I'm not going to stop the meeting. I'm going to stop the recording.